All right, today we are going to unlock a superpower. And believe it or not, it's hidden in plain sight. Inside what might be the most famous equation in all of algebra, y equals mx plus b.
No, really, I am not exaggerating. This simple little equation, it's an absolute powerhouse. It's like a universal language for math, showing up everywhere from, high-level science and engineering, all the way down to that graphing calculator you've probably got in your backpack.
And that right there is its secret. See, it's a map. It's basically a set of instructions that tells you how to draw any straight line you can possibly imagine. It literally tells you exactly where to start and exactly where to go, all packed into one neat little formula. So, you ready to unlock this thing? Ready to learn how to read the map? Let's dive in. Okay, first things first, we gotta understand the anatomy of the line itself. We're gonna break this equation down into its two most important parts, the m and the b. Let's start with m. M stands for slope, and the slope tells you exactly how the line moves, right? Is it super steep? Is it kind of flat? Is it going up or is it going down? All of that is decided by m. You've probably heard of it as rise over run, which is really just a fancy way of saying how much the line goes up for every single step it takes to the right.
And then we have b, that's the y-intercept. So if the slope tells us how the line moves, the y-intercept tells us where it all begins. It's our starting point, the one exact spot where our line crosses that vertical y-axis on the graph. So when you put them side by side, it's pretty simple. M is the movement, the rate of change. B is the beginning, the fixed starting point. Every single straight line has these two things, and with y equals mx plus b, we can spot them instantly. All right, so theory's great and all, but let's see how this thing actually works with some real numbers. We're going to decode a few equations together. Let's start with a nice simple one, y equals 2x plus 5. Our only goal right now is to find m and find b. It's a super simple two-step process. Step 1, just find the number that's attached to the x. That's your slope. In this case, it's 2, so m equals 2. Step 2, find the number that's all by itself. That's your y-intercept. Here, b is 5. So our line starts at 5 on that vertical y-axis, and from there it goes up 2 for every 1 it moves over. Okay, let's try another one, this time with some negative signs. We've got y equals negative 1/2 x minus 3. Now, listen up because this is where a lot of people trip up. You have to watch the signs. The slope isn't just 1/2, it's negative 1/2. And the y-intercept, it's not 3, it's negative 3 because we're subtracting. You got to remember, that sign is part of the number. It sticks to it like glue. Okay, how about this one? Y equals x. Where are the m and the b here? It kind of looks like they just disappeared. Well, they didn't disappear, they're just invisible. In algebra, we don't usually write a 1 in front of a variable. So when you see x, it's really 1x. That means our slope, m, is 1. And what about b? Well, since there's nothing being added or subtracted, our starting point is just 0. The line starts right at the origin. Okay, you're getting the hang of this. So let's talk about the two biggest traps that students fall into. Knowing about these ahead of time is going to save you a ton of headaches, trust me. So pitfall number 1, a lot of people will say the slope is 3x. That is absolutely wrong. The slope is the rate, right? It's how things are changing, and that's always just a number. The x is the variable, so for y equals 3x plus 1, the slope is just 3. Simple as that. The second trap is all about order. Take a look at this. Y equals 5 minus 2x. Now, it is so tempting to just look at it and say the slope is 5 because it's the first number you see. But you have to remember the rule. The slope is always the number attached to the x. The absolute best thing you can do here is just rewrite it first. Get it back into that familiar y equals mx plus b format. So y equals 5 minus 2x, we just swap it around to become y equals negative 2x plus 5. And boom, now it's crystal clear. The slope, m, is negative 2, and the y-intercept, b, is 5. So, why are we doing all this? I mean, why is this one equation so important? Because it's not just about drawing lines on a piece of graph paper. Let's see how this pops up in the real world. Let's think about taking a taxi or an Uber. You know how it works. There's almost always a flat fee just to get in the car, and then there's another charge for every mile you go. Does that sound familiar? It should.
because it maps perfectly to our equation. The pickup fee, let's say it's $5, that's your fixed starting point. That's our B. The cost per mile, we'll say it's $2, that's your rate of change. That's your slope, M. So the total cost, y, is just 2 times the number of miles, x, plus that initial $5 fee. See? Y equals 2x plus 5.
And that's the superpower. That's why this is so cool. When you write it out this way, you can instantly see the two most important parts of the price, the one-time fixed cost and the variable cost that changes depending on how far you actually go. So I'm going to leave you with this idea. A taxi fare. That's a straight line story. A cell phone plan with a monthly fee and then a charge for every gigabyte you use. Yep, that's another straight line story. Now that you know how to speak the language of y equals mx plus b, I want you to think, what other straight line stories are out there, hiding in plain sight, just waiting for you to come along and decode them?